Assalamualaikum everyone, welcome back to mathematics, and I'm Askanur, and today the paper that we are going to solve is A-level CI's statistics paper code 9709, variant 52, May June 2025. So let's begin with question number 1. Rachel has 3 coins. The first coin is biased, so the probability of obtaining a head when it is thrown is 1/3. The second coin is biased, so the probability of obtaining a head when it is thrown is 1/4. And the third coin is fair. So first let us understand this visually. Okay, so these are your 3 coins. Okay, the first is biased, the second is also biased, and the third is fair coin. The probability of getting a head in the first one is 1/3. In the second one, obtaining head probability is 1/4, and obtaining head in the last one is 1/2 because it is a fair coin. Now first understand what is a fair and what is a biased coin. A fair coin is a coin where all the, like, if we are not specifically talking about coin or like a dice or any spinner, if it is a fair, then it means that all the outcomes are equally likely to happen. Equally likely means if the probability of getting a head is, in case of a coin, if it is head is 1/2, then the tail will be 1/2, 50-50% chance of each. Okay, in case of a dice, if it is fair dice, then the probability of, as we have 6 outcomes, so probability of getting each outcome will be 1/6 for all the 6 outcomes, 1 to 6. Okay, this is a fair coin or fair dice. Biased is when some outcome is more likely to happen than the other. Like for example, we have listened about that the ball is tempered. So in the same way, if the coin is tempered in a way, or it is melted or molded in a way that there are more chances of getting a head than to get a tail, then it means it's biased. Okay, it has some biasness. And whenever there will be a biased coin or a biased dice or a biased spinner, they will always give you the probability for that, like they have given you here for the first 2 coins. Okay, second thing is that the sum of the probabilities in any event is equals to 1. So the probability of getting a tail in the first coin will be 1 minus 1/3, that is 2/3. For the second coin, the probability of getting a tail would be 1 minus 1/4, that will be 3/4. And for the fair one, we know that both will be 1/2 and 1/2. So this is all. Now let's read the rest. Next part of the question, they say the Rachel throws 3 coins at the same time. The random variable x is the number of tails that she obtains. They draw up the probability distribution table for x. Okay, they have defined your random variable x to be equals to how many number of tails we get. So, and we need to make a probability distribution table for x equals to number of tails, or you can just simply write tails. Okay, so how will we make it? First we'll write the values x. So we can have probabilities. Okay, we'll make a table after understanding all the scenario with the help of a tree diagram. So let's see. The first possibility is that in the first coin you get a head and you get a tail. For the first coin, we know the probability is 1/3 and 2/3 for head and tail respectively. Then we have for the second coin, we can have a head or a tail, head or a tail, head or a tail. And what is the probability of getting head on the second one? 1/4, 3/4, 1/4, 3/4. Now we are talking about the third coin. So in case of a third coin, the probability of getting a head is 1/2 each, head or tail. For the next branch also, head or tail, 1/2, 1/2. For the lower branches also, we will have a head or a tail, head or a tail, and the probabilities are same, 1/2, 1/2 for each. So this is your tree diagram representing that 3 coins are thrown at the same time. Now we need to make the probability distribution table. Okay, what are the chances of getting a head or a tail? Just a little more to the left, because we know we need 4 values. Okay, and what are those 4 values for probability? We want to be taking the probability of getting 1 tail, 2 tail, 3 tail, 4 tail. Rather, the possibility start off with, we can have a 0 tail. That means 0 tail, that means you have a possibility of head, head and head. Then you can have 1 tail. 1 tail possibilities are head, head, tail, head, tail, head, tail, head and head. Okay, then we can have the possibility of getting 2 tails. 2 tails can have tail, tail, head, head, tail, tail, and tail, head, tail. These are the 3 possible outcomes in case of 2 tails. And lastly, we can have 3 tails, and the probability of that happening is tail, tail, tail. So yeah, now here we will be writing up their probabilities, and their we'll solve them out. Okay, so starting off with head, head, head. So this is the branch that tells you head, head, head. And what is the probability for it? The probability is 1/3, 1/4, 1/2. 1/3 times 1/4 times 1/2. That gives you 1/24. Then the probability of getting head, head, tail would be head, head, tail, head, tail, head, tail, head, head. Okay, these are the 3 branches. So head, head, tail would be 1/3, 1/4, 1/2. The same, 1/4, 1/2. Head, head would be 1 over 3, 3 over 4, 1 over 2, and tail head would be 2 over 3, 1 over 4, 1 over 2. Okay, so this gives off you 1 over 24. The second gives you 3 over 24. Okay, you could see that we can simplify this 3 and 3, but I'm not doing that. It is always better not to do this, because at the end, when you sometimes need to add the probabilities, you need a common denominator. Now it is already a common denominator, but if you cancel it out, you again have to make a common denominator, and then you have to solve. So it is better to keep it in the same way, okay, so that you can start off with, you can just add them easily. So 2 over 24. Okay, now write down the probabilities of the next 3 possibilities. That we have to be 2 tails is tail head, sorry, no, tail head, head tail, and tail head tail, head tail. All these 3 possibilities we have taken. Now okay, tail head is 2 over 3, 3 over 4, 3 over 4 times 1 over 2. Head tail will give you 1 over 3, 3 over 4, 1 over 2, and head tail will give you 2 over 3, 1 over 4, times 1 over 2. And the last is, let me counter check this, tail head is 2, 3, 1, head tail is 1, 3, 1, and tail head and tail gives you 2, 1, 1. Okay, I hope so this all is correct. Now let's move to the last probability, and that is tail, this branch. So tail probability is 2 over 3 times 3 over 4 times 1 over 2. Now multiply them together, you will get 6 over 24, 3 over 24, 2 over 24, and 6 over 24. So these are all the probabilities. Now one thing, that one tail, what is this scenario giving you information? That in one tail you can have head and tail, or you can have head, tail and head, or you can have tail, head and head. So there is a case of or, that means you have to add all these together to get the final. So 1 plus 3 plus 2 gives you 6 over 24 when you add them together. Comes 6 over 24. Secondly, the 2 tails also will be added up together. It is the scenario where you have tail head, or head tail or tail head tail. So you have to add them together, and they will add up to give you 6 plus 3, 9. 9 plus 2, 11 over 24. Okay, so write them up. These are your 4 probabilities that you need to mention in your given space, and that is probability of getting a 0 tail is 1 over 24. Probability of getting 1 tail is 6 over 24, 2 is 11 over 24, and 6 over 24. Okay, so that's all about it. You can also write them out in the decimal form, okay, or simplified form. Also, to check if you have found it correctly, you can all add these all to get, if you get 1, that means it's correct working. Okay, so I just want to write them in decimal form also. So this gives you 0.416. 6 over 24 gives you 0.25. 0.4583, and 6 over 24 again gives you 0.25. Okay, so these are the same probabilities in decimals. I'm writing them in the different colors. So that's it. This is all of your working for your probability distribution table. This is the actual table. The actual solution is this that you have to do. The rest is all working and to make you understand how it will be. So I hope you understand this question. That's all about question number 1. Thank you. Allah Hafiz.